Okay, so today what we're going to talk about is translating parent functions. So we've learned about all 8 of the parent functions, and now we're going to talk about how we can move them and how they're related to each other when they get moved. Okay, so we have a formula for translated parent functions. So the general formula is f of x equals a f of x minus h plus k. Our a value stands for our vertical stretch or shrink. Okay, our h value stands for our horizontal movement. And our k value stands for our vertical shift. Alright, so in every function that we do, no matter what it is of the 8 parent functions, we will use this formula or this order to decide what's happened to it. So the difference is where this f of x thing comes in. So say we had a quadratic function, we could say that it's a x minus h squared plus k. We have the absolute function, it would be a absolute value x minus h squared plus k. If we had the cube or the square root function, we have a square root x minus h plus k. Alright, so it doesn't matter which function it is, the order of the translations are the same. And notice that the equation has a minus sign, so that's going to affect something when we do a horizontal translation. Okay, so let's talk about horizontal shifts. Alright, a horizontal shift occurs when the x values of a parent function are changed. So if we want to move the graph to the right, we end up having to add h to our function. But because of that minus sign, when we put in a positive h, the minus sign is going to stay the same. So we end up with x minus h. So in this function, even though it says x minus 3, we're really going to the right 3. So basically, you need to think about it backwards. All right, for a left shift to occur, we do the same thing. We're plugging in a negative h, meaning a negative movement, into our equation. But because of this negative sign, we end up with x plus h. All right, so when you see a plus 3 inside of the parentheses, that really means you're going to the left 3. So whenever you are talking about the horizontal shift, you take the number and you take the opposite sign, or the sign tells you opposite of the direction you're going. So if it's a plus, it's to the left, a minus to the right. Now vertical shifts are a little bit more common sense. So vertical shift shifts the graph either up or down. So an upward shift is just like you would think when you see a plus 3, that means you're going up 3. If you see a minus 3, you're going down 3. So horizontal is the only one where we have to do a little bit of thinking about opposite directions. So let's do an example. Say we had the graph, or had the function, f of x is equal to x minus 1 squared plus 3. All right, this is a quadratic function, so let's graph that real quick. Okay, remember that the parent function sits at the origin, and we have a dot at the origin, and we go up 1 over 1, over 1 over 1. We go up over 2, up 4, and then we match it on the other side. So this is the parent function. I'm going to draw it as dotted because that means that's our original function. Now to translate this minus 1 tells me I'm going to go to the right 1. This plus 3 tells me I'm going to go up 3. So if I wanted to graph it here, the reason I have critical points is because I'm going to use those points to move the entire function. So this point here is going to move over 1, and it's going to go up 1, 2, 3, and that's going to be its new dot. Okay, this point's at 1, 1. I'm going to go over 1, and I'm going to go up 1, 2, 3, so the new dot would be up here. This dot's going to go over 1, go up 1, 2, 3, and it's going to be here. So my translated function ends up being way up there. But I used my critical points to determine where the new graph would sit. If you didn't have any points, then it would be hard for you to figure out where the points move. Let's try another one. So say we have f of x equals, let's say, the negative absolute value of x plus 1 minus 2. So if I graph this one, I always graph my parent function first to show myself that where the original graph sits. So this original graph is absolute value, so it's going to have a point at 0, 0. It's going to have a point at 1, 1. It's going to have a point at negative 1, 1. It's going to have a point at 2, 2. And at negative 2, 2. Because remember, the absolute value function is the b function. B for absolute value. Oh, I should have done that dotted. Let's erase that a little bit. So let's erase. Alright, so it should be dotted because it's our parent function, so we're going to dash it. Sorry, my fault. Alright, so it's dashed. Now, what does this negative sign do? Well, a negative in the front reflects it across the x. So it's going to make this graph end up going downward. Okay, so let's go ahead and say that it's going downward, and we reflected it this way. So now we're going to translate it. This tells us we're going to go to the left 1, we're going to go down 2. So I'm going to just translate this point, because if I know where that point lies, then I can easily fill in this function, because it always goes over 1, over 1, over 1, up 1, or so on and so forth. So I'm going to take this dot, I'm going to go to the left 1, and I'm going to go down 2. So my new point sits at negative 1, negative 2. So my next point on the graph would be down, it would be over 1, down 1. It would be over 1, down 1, because that's how the parent function sits. So this graph actually goes this way, because it's been reflected. Now my graphs aren't very exact, because I'm doing it by hand, but you get the idea. Okay, so what we're going to focus on is identifying the translations, whether they're horizontal or vertical, and graphing the new function. Okay, so whenever you graph a parent function translation, you graph the parent function first, and you dash that line, and then you draw the translated graph. That way you can see where it came from and where it's ending up. The other thing to remember is that with parent functions, the critical points are critical. That's why we use them. So you always should draw at least 3 of the critical points so that you know where the graph is going. And most often, it's the critical points surrounding the 0. Alright, so make sure you take good notes of this. We will go over it first thing in class tomorrow if you have any questions. So make sure you write down anything you're still confused on. Okay? Have a good night.